When you run a program, it is the CPU that is responsible for analyzing instructions, for carrying out instructions, for doing all the math. Now, before you can ever get the program to the CPU, it must go into RAM. All programs, no matter how big or small, are copied from secondary storage into RAM before they're sent across to the CPU for execution. The CPU executes is in a constant fetch, decode, execute cycle where it fetches the next instruction from memory, it decodes it, which means analyzes it, sees what part of the system is required to carry out that instruction. For example, if you're saving directly to the disk, there has to be a drive in the disk that you're trying to save to. And execute it actually performs the operation. So here's the graphic from your book, figure 117, that tells you the fetch, decode, execute cycle. Now, when we talk about programming languages, we have to start at the beginning. In the beginning, there were machine languages, which is languages of zeros and ones. And it was not fun to program in those languages. I have done it myself, and it was not easy. Okay. Assembly language is another type of language which uses short words. It's not just zeros and ones, but it uses short mnemonics such as add AX, comma, BX, etc. An assembler is required to execute an assembly language program. Then we come to assembly language is a low-level language. After that are high-level languages. These allow you to write in a more English-like format. They're easier to understand and they're easier to write. You don't need to write at the CPU level to write high-level language programs. Now, some things about high-level language programs. First thing is, every high-level language has something called keywords. They're also called reserved words. These are predefined words that are used to write a program. They are part of the program. For example, in Python, print is a keyword. If is a keyword, else is a keyword. They have predefined meanings in the language, and the programmer cannot redefine those meanings. Now, there are other identifiers in the program that the programmer defines themselves. We'll get to them in Chapter 2, or in Competency 2, in which you write a complete program. You also have in programs operators, arithmetic operators, plus, minus, multiply, divide. Then you have a set of rules that needs to be followed. And this set of rules is called the syntax. Syntax are the grammar rules in the program that you must follow when you write the program. Every single program instruction is called a statement. Every statement in a program carries out one instruction. Now, there are two things you need to know related to programs. They're compilers and they're interpreters. Compilers take a whole program and they translate it from a high-level language to machine language, provided the program has no syntax errors. If the program is free of any kind of syntax errors, then a translation is made. There is a machine language file that is created, and this is the file that is executed. C++ is a compiled language. Python is not a compiled language. It's an interpreted language. Interpreters translate and execute instructions in, again, just like a compiler, except they interpret and translate one instruction at a time. They don't create a separate machine language program. Both compilers and interpreters work on the source code. Source code is what you create as a programmer. You'll find out more about this when we get to future modules. Right now, just let it suffice for you to understand the source code is the statements that are written by you. And there are three types of errors that can be produced. There is a syntax error, the logical error, and the runtime error. Syntax error, very simply, is the error of language, where you haven't used the language properly. A logical error, for example, if I ask you to write me a program that converts from feet to inches. So if I give you 2 feet, that should convert to 24 inches. Okay. Instead, you have a program that converts 2 feet to something like 1 point something inches, and which means instead of multiplying by 12, you're now dividing by 12. Your program runs, The interpreter throws no syntax error. The program runs just fine, but it produces bad output. Similarly, when you're converting from inches to feet, if I ask you to convert 12 inches to feet, it should convert to 1 foot. But I find that when the program runs, it converts it to 144 feet because you multiply it instead of divide it. Logical errors are not that hard to find. You just have to go through the program one statement at a time. When I worked at IBM, one of the programmer manuals told us that in order for the programmer to understand that the error that's coming, the programmer literally has to get into the mind of the machine and think from the point of view of the machine. The last type of error is a runtime error, which is relatively hard to find because you don't know what's happening. Your program might just unexpectedly crash. Your program may not do anything. It just sits there and spins. So those are the errors where you really need to then go through your code very carefully and see, write out what each statement of code is trying to do. Now, here is where I'm going to give you my little spiel about planning. You must plan your programs. My favorite saying is, hours of planning can save you weeks of programming. If you plan out your programs, if you logically plan out your programs before you start writing the code, you will run a lesser risk of running into syntax, logical, and runtime errors. And this is just a graphic of how the interpreter works. In the next video, we'll actually look at doing some Python script. And till then, enjoy.